Next, we're going to take a look at a couple theorems, a few patterns and different things with finding sums. First one, theorem 4.10, we have the sum from k equals 1 to n of c, just a constant. We saw that a couple times in our practice problems. Here we had the sum when c was 3. We had 5 terms. All we had to do was do 5 times 3. We got 15. Here our constant was 11. We had 4 terms. 4 times 11. So in general, if we have the sum of a constant, all we have to do to figure out that sum is take that constant times the number of terms. Pretty simple one. We don't have to write it out every time. It's constant times the number of terms. Now, that n only works if we're starting when k equals 1. If we had something like this, k equals 0 to n of c, do we still have n terms total? We've added 1. Instead of starting at 1, we're starting at 0. So this would be the constant times n plus 1. So for example, if we went from 0 to 3, like we did earlier, that wasn't 3 terms, that was 4 terms. So it's going to be the constant times the number of terms. So it could be n plus 1 if we're starting either one of these. Now, theorem 4.11, you'll see, is very similar to a theorem we were talking about with integrals. When we have a sum of a sum, when we have two different ones that we're adding up, we can split those up into two separate sums. Just like we did with integrals, just like we did with derivatives, just like we did with limits. It has the same property. We can split up that sum. We can also split up a difference. Break it into smaller pieces to make it easier. And also, if we have a constant times that sequence, just like we were talking about before with antiderivatives, limits, and derivatives, we can just leave that constant out in front and multiply it by the sum. Alright, so those should all look kind of similar to things we've already talked about, only different notation out in front. Here we have a sum, a sigma notation, rather than an integral or a derivative or a limit. Those two theorems are relatively easy, simple things that we've kind of dealt with before here, and this one's just pretty basic. These next three are a little bit more involved, and these are ones that you definitely need to memorize. So, for number 1, if we have the sum of just k, so that means 1 plus 2 plus 3 all the way up to n. This is one that you guys learned last year, or a variation of this. So let's look at an example here. What if we had this sum for the first 6 terms? So we're adding 1, 2, 3, 4, 5, and 6. Now, that's not too hard to add up, but can any of you find a pattern in how to do that without having to add every single one? For instance, if we got something a little bit larger, like the first 100 terms, how could we do that? Take a second to think about it. Alright, you may or may not remember, there's a little bit of a pattern here. If we add the first and the last term, that's going to give us 7. Add the second term and the second to last term gives us 7. The next ones also give us 7. So what we have to do, we have a total of 6 terms here. If we take the number of terms divided by 2, that gives us the 3 pairs that we just saw. 3 pairs of numbers that all add up to 7. Then we have to multiply that by the first term plus the last term. Or we can write it as n plus 1, right? N being our last term plus our first term. So our formula for this, when we just have k, is n times n plus 1 all over 2. Now, number 2 and number 3, a little bit different. Not expecting you to kind of figure those out on your own, but you will need to remember them for the problems we're going to do here in a little bit. So for number 2, we have n times n plus 1 also, but on top we also have to multiply by 2n plus 1, and this is all over 6 rather than 2. So that one's a little tougher to remember. Third one isn't so bad if you can remember the first one, because all it is that first one squared. So if you can remember the first one, the third one shouldn't be too bad. Second one's probably the toughest out of all three to remember. But we're going to use these to evaluate some series. Today, again, just kind of some practice and review and learning a few things about series and sums. But this is all going to tie into integrals in the next few days.